Hello everyone. Today I decided to talk about integrals, and I'm going to begin with basic of integrals, partial method, the integrals of trigonometric functions, the rational integrals and irrational functions. How we can integrate some irrational functions. That is not hard, but is I think that is quite tricky. Now I'm going to begin with something which maybe you can think that is not we cannot derive those things, but we can derive the integral in the summation form, in surface problems and those things. But for now we are going only to talk about how to solve the integrals, and then we can derive something. So we write like this: the integral. This is the integral, like s, for because it's the sum of f of x dx is equal to, we can say that is equal to some other function which we call f, a big F of x, plus some constant c, where this is the c is element of the real number line. So now maybe we should talk about what is this f, big F. Big F sometimes is called a primitive function. This color is not good. Primitive function. And I would like to write something that integral is opposite thing of derivative. So why this is important? This is important because you need to understand this function f, this function of f. For example, if we take the derivative of this function f of x, so f, we call this f prime of x, this function should be equal to this f of x. So this is the primitive function. For example, the integral of x to the fourth dx is equal to x to the 5 divided by 5 plus this constant c. So now if we take the derivative of this one, x to the 5 divided by 5 plus c in derivative, this is going to be x to the 5 divided by 5 in derivative plus c in derivative. The derivative of this one is 5 x to the 4 divided by 5 plus the derivative of c, of the constant. This is the constant. Is 0. Then 5 goes with 5, and that is x to the 4th. So when we take the derivative of this big F, we should or we must take this function. So this is very, very important in integrals. some properties of integrals are, for example, if we have f of x plus g of x dx, then it would be equal to f of x dx plus g of x dx. We can plus or minus. Or this is first one. The second one is, for example, the integral of constant times f of x dx is equal to, the constant goes before the integral, c times integral of f of x dx. So this dx means that we have to integrate with respect to x. We can, for example, we could have the integral of f of y dy. So we should take the integral with respect to y. So this tells us that with what we take the integral. And now I'm going to begin with some elementary functions. For example, if we have the integral x to the n is the natural number, so dx, this is going to be x to the n plus 1 divided by n plus 1 plus c element of real number and element of natural number. For example, the integral of x to square dx, this is equal to, so the n now is 2, the n, so we could write that n is equal to 2, so now it would be x 2 plus 1, 2 plus 1 plus c. This is equal to x to the third divided by 3 plus c. So and when we take the derivative of this one, x to the third divided by 3 plus c, in derivative this is going to be 3x squared divided by 3, and this is x squared. So this one is equal to this one. So this is the basic integral formula, one of the basic. So x to the n dx, x n plus 1 divided by n plus 1 plus c. We have some other fundamental integrals. For example, integral 1 over x dx is equal to the natural logarithm of x, ln of x plus c. Or we should write that ln is in absolute value of x, because this x cannot be negative, so x is equal is bigger than 0 here. Because why this is true? Because when we take the ln of x in derivative, so this is going to be 1 over x. So this is quite simple. Some other integrals are the integral a to the x dx, which is equal to ax divided by ln of a plus c, where a is the element of the real number, only plus real numbers, but don't the one is not included here, so except of 1. The fourth is the integral of e to the x dx. This is e to the x plus c, because when we integrate e to the x plus, when we take the derivative of e to the x plus c, that is going to be only e to the x. The fifth integral is sine of x dx, which is minus cosine of x plus c. The sixth one is the integral of cosine of x dx is sine of x plus c. The seventh one is going to be the integral of dx divided by cosine squared of x, which is the tangent of x plus c, because when we take the derivative of tangent, it would be 1 divided by cosine squared x. The eighth one is dx over sine squared x, which is minus cotangent of x plus c. And one other one is dx 1 plus x squared, which is arccos tangent of x plus c. And the last one is the integral of dx, the square root of 1 minus x squared, which is arccos of sine x plus c minus arccos cosine plus c. For now, we are going to do some examples. For example, we have the integral of x times, this is x, sorry, this is x times the square root of x dx. So what we do is the integral of x times, this one is x to the power 1.5 times dx, and this is the integral of x 1 plus 1.5 dx, the integral x to the power 3 over 2 dx. And so now we apply this formula, x to the n dx, which is xn plus 1 n plus 1 plus c, where n now is equal to 3 over 2. So it would be x to the 3 over 2 dx, it would be x 3 over 2 plus 1, 3 over 2 plus 1 plus c, and this would be equal to x 5 over 2, 5 over 2 plus c, and this is going to be equal to 2 over 5, because the opposite times x 5 over 2 plus c. So this is the integral. The next example, maybe we can do the integral of 2x4 in the power 4 plus 3x squared plus 5x plus 4 dx. So this is equal to integral of 2x to the 4 dx plus the integral 3x squared dx plus the integral 5x dx plus the integral of 4 dx. This is going to be equal with the 2 here is a constant, so goes before, times integral of x to the power 4 dx plus 3x squared dx plus 5x dx plus 4 the integral of dx. This is equal to 2 times n is here 4, so it be x 4 plus 1 plus 3 times x 2 plus 1 2 plus 1 plus 5 x 1 plus 1 1 plus 1 and plus 4 times. So this integral is only x. Remember in the beginning we said that the integral and the derivative are the opposite things, so they cancel each other, so only in this case plus only one constant here, so we can put one constant here, one here, one here, one here, and we can sum c1 plus c2 plus c3 plus c4, which is equal to c, and this one is equal to 2 over 5x to the 5 plus 3 over 3x to the 3 plus 5 over 2x squared plus 4x plus c, and this is equal to 2 over 5x to the 5 plus x to the 3 plus 5 over 2x squared plus 4x plus c. This is the integral. So I would do maybe some other examples, like the integral of minus ln of pi divided by x squared, ln of pi divided by x squared dx. So minus ln of pi is a constant here, so this part here goes out. This is equal to minus ln of pi 1 over x squared dx, and now minus ln of pi x to the minus 2 dx. So now n is equal to 1, so the integral x to the n dx is x to the n plus 1 n plus 1 plus c, and this is equal to minus ln of pi times x minus 2 plus 1 minus 2 plus 1 plus c, and this is equal to minus ln of pi, so times x to the minus 1 here. Minus divided by minus is plus, so ln of pi times x to the minus 1 plus c, here is plus c, which is equal to ln of pi divided by x plus c. Okay, maybe I can do one more example, but I am looking for trivial examples, because so maybe this one, next one is quite good. Okay, the integral of x plus the square root of x divided by the third of x, the third root times dx. So the first thing that we do here is to separate those two things. So we can do like this: x divided by the third root of x dx plus the integral the square root of x the third root of x dx. And now we can do like this: x x1 in a power 1 over 3 times dx plus x in a power 1 divided by 2 x1 divided by 3 dx, which this one is equal to x times x to the power minus 1 divided by 3 dx plus the integral x 1.5 times x minus 1 over 3 dx. This is equal to x1 minus 1 over 3 dx plus x1 over 2 minus 1 over 3 dx. So now x 3 minus 1 is 2 over 3 dx plus x 6 1 over 6 dx. So for this integral n is 2 over 3, and for this one as n is 1 over 6, and this one is equal to x 2 over 3 plus 1 2 over 3 plus 1 plus x 1 over 6 plus 1 x 1 over 6 plus 1 plus c, and this is equal to x 3 2 plus 3 2 plus 3 over 3 plus x 6 1 plus 6 x 1 plus 6 over 6 plus c, and this is equal to x 5 over 3 plus x 7 divided by 6. So this is wrong, this is not x, only this one, 7 divided by 6 plus c. And now we have 3 over 5 times x in the power 5 divided by 3 plus 6 over 7 times x in the power 7 over x plus c. So those was some example of integrals, and in the next lecture I'm going to do some example when we take the substitution method. So we have to substitute the variable, for example, from x we have to move in other variable, for example u, t, v, and something, whatever you want to call that. Thank you very much. See you in next lecture.